Hello everyone and welcome. This is a new tutorial. My name is Ahmed and in this lab we are going to demonstrate how we can use the AWS build stack to deploy a complete CI/CD pipeline. CI stands for continuous integration while CD stands for continuous deployment and continuous delivery. There are many definitions online for CI and CD. For the sake of completion, I'm just going to have a very quick refresh over those definitions in case some of you are not familiar with them. So, continuous integration or CI refers to the process of keeping the code always in a deployable state in the sense that it is always tested, it is always quality code that can be deployed to a staging or even to a production environment at any point in time. This involves having this code checked each and every time it is committed to the Git repository. Automated testing is run against the code, and it is also tested for integrating with other components in the application, in case we are talking about a microservice application with many small components that interact with each other, while continuous deployment and delivery refers to the process of continuously putting the app into an environment where it is ready to be shipped to production. So whenever tests have passed in CI stage, code is then pushed into a staging environment or a testing environment where further tests may be applied on that code. And then maybe to complete the whole circle, code can be also pushed to production. However, most of the cases, this step is not automatic. This step is always manually triggered so that there is always some sort of control over which code gets shipped to production. Okay, I think this is a brief introduction. Now you have a basic familiarity of CI/CD. Let's see now how we can do that using the AWS build stack. The AWS build stack refers to the following products: AWS CodeCommit, AWS CodeBuild, AWS CodePipeline, and AWS CodeDeploy. In this specific tutorial, we are not going to use the AWS CodeDeploy. I will achieve the same target using AWS CodeBuild, so we needn't use CodeDeploy. In this diagram, you can see how each and every component talk to each other and how code transitions from one stage to another. I will get back to this diagram several times during this video in order to emphasize which stage we are in and what exactly we are doing. So, without any further ado, let's start deployment. So the first thing we are going to do is, of course, build our app. For sake of simplicity, we are not going to build anything fancy. We are just going to have a very simple API that displays hello world to HTTP requests. We are going to use NodeJS for that. So in the terminal, I'm just going to create a directory called app, then cd inside that directory, and then I'm going to create our main file, index.js, and I'm going to paste our application code. So you don't have to be a Node.js developer to understand this code or to follow this example. It's very simple. It's just creating a web server, as you can see here, and it is configuring port 3000 as the port that this app will listen at. Then it defines only one route, which is the slash. And whenever somebody establishes an HTTP request to that route, the server is going to respond with the JSON message, hello world, right? So let's save that file. And if any of you have worked with Node before, you know that in order to create a Node app or to work with Node, we must initialize the application using npm. So that is what I'm going to do. I'm just going to initialize an empty app, and I'm going to answer yes to all the questions that npm is going to ask me. This creates a package, the JSON file, which is some sort of a manifest of the application, how it should run, who wrote it, the Git repository, and so on. So once package.json has been created, I need to install whatever packages I need for this application to run. In our specific case, I only need Express for the time being. So I'm going to npm install Express. Now all what I need to do is run the application by typing node index.js. It's listening at 3000. Now if I open a new tab and I run curl against localhost port 3000, I'm gonna see message hello world. This means that the application is indeed running. All right, so let's exit from the application. And since our application is a microservices one, we are going to use Docker to serve that application. Using Docker ensures that you can run your application anywhere on any machine that supports Docker. And if you are using a containerization software like Kubernetes or AWS ECS or even Docker Swarm, then Docker is your first and only choice here. So in order to create a Docker image, I'm going to create a Docker file. So let's create a Docker file in the same directory of our application. And I'm going to add the Docker code. The first line just ensures that we are using Node as our base image. The second line ensures that we are in the correct directory, which is app. Then we are just adding the index.js and package.json to the working directory. We do not have any other files for the application, only the index.js and the package.json. Then we run npm install to install whatever components we need. In our case, we only have Express. Then we inform the user that we are going to run this container, or this image is going to run a container that will listen at port 3000, so that when they run our container, they know that they need to expose that port so that people can access the app. Finally, we have the entry point that uses Node as the application and then index.js as its argument. And that's it. Let me save the Docker file. And now let's ensure that the application is still working when run through Docker. So I'm going to run Docker build -t for the tag. I'm gonna call that example app. Then give it the dot to refer to the current working directory. Now Docker is building this image, right? The image is built successfully. Let's clear the screen and run Docker run -p 3000, which means that we are going to expose port 3000 from the container to port 3000 on the localhost on our machine. -d to run that in the background, and then example app as the name of the image that we have just built a few seconds ago. Pressing enter, I have a container running in the background. Now I'm going to again use curl to establish an HTTP request to localhost at port 3000, and again I have message hello world. This means that my Docker container is running. So let's kill that container. And this completes the first step of our CI/CD pipeline. We created an application, we Dockerized the application. Now it's time to push that image to a Docker registry. Now that we have correctly created our image, we need to push it to some repository. In this example, I'm going to use AWS Elastic Container Registry, or ECR. However, this is not a requirement. You can use whatever repository you need, whether it was ECR, GitLab, GCP, QA, or even Docker Hub. It's your own choice. It will not make any difference. But for this lab, I'm going to use ECR, so I'm going to sign in to the AWS console. And I'm going to use the Elastic Container Registry, get started. And I'm going to choose a private type of registry and create a repository name example app. I'm going to leave the rest of the options to the default. I'm going to click create repository. And then I need to keep a copy of this URL because I'm going to need it in order to log in to the repository and in order to be able to push the Docker image there. So I'm going to return back to the terminal, and I am going to first log in to the repository by using the AWS ECR get login password. Then I pass the region, which is EU West 1. Your region may differ. And then I pipe the output to Docker login -- username AWS, which is constant. And the password is going to be taken from the standard input. Then I pass in the URL or the prefix of the repository, which is the exact string that we copied from ECR, except that it does not have this, the name of the app. So just the prefix of the repository is needed. Of course, you need to have programmatic access to your AWS account and the proper permissions to do this. I'm going to click enter. And now I have successfully logged into my ECR account. The second step I need to do is to tag the image, tag example app image with the prefix of ECR plus the name of the repository. And this step will be required whenever you want to push to another Docker registry other than Docker Hub. Docker Hub is the default repository to push to if you do not have any prefix for your image tag. But if you want to push to another repository, you have to prefix your repository name with the URL of that repository, which is in our case ECR. Pressing enter, now I have successfully tagged my image. The final step is to actually push that image to ECR by using docker push. Alright, and now the image is pushed. I can now go to my ECR repository, click on example app, and now I can see that I have an image of the tag latest that has been just pushed. This is the size, and later on we'll see how we can select the image tag that we are going to push to. But to do that, we'll first need to move to our next step, which is creating our CodeCommit repository. The first step in any CI/CD pipeline is to have a Git repository. This will be the single point of truth for your code. This is where the Git history resides, and this is the source of all the deployments and all the actions that will follow. Go to CodeCommit, which is AWS's own Git service. I'm going to create a repository. Again, I'm going to name it example app. You can add a description if you want and some tags, but I'm not going to do that. I'm just going to leave the name as is and then click on create. Now, the second you create a repository, you need to define how people are going to access it. So I'm not going to go through the Iam roles and who has access to what. I'm just going to create a simple user and use that user account to access the CodeCommit repository. As you can see here, we have different types of access. We have HTTPS, SSH, and HTTPS GRC. I'm going to just duplicate this tab because I don't want to lose it. And then I'm going to go to services, IAM, go to users, and going to add a user. I can call this account CodeCommit user. And this user will not need programmatic access because we're not going to use this user except to push code to CodeCommit. I'm going to add permissions and going to choose attach existing policies directly. I'm going to choose CodeCommit, and I'm going to give this user full access to the repository. There will be no tags, and create user. Alright, I'm not going to download a CSV file for this user because again, I'm not going to use it. However, once it's created, I'm going to click on that user and then go to security credentials. And down here, I can see that I have HTTPS Git credentials for AWS CodeCommit. I'm going to click on generate credentials. This is what I need. I'm going to download those credentials as a CSV file. And now I can go back to the terminal. Let's clear the screen. And let's create a CodeCommit repository for this app. I'm gonna start with git init to create an empty Git repository in this directory. Then I'm going to use this command git remote add origin, and then I'm going to supply the URL of our git commit repository. This can be gotten from here. Just gonna click on this to copy the HTTPS URL of our CodeCommit repository, paste it here, click enter, and last I'm going just to ensure that we don't add unnecessary files or directories to our repository. So node modules is a directory that gets created whenever you run npm install something, and since this directory is going to be created whenever we run this command, so we definitely don't want to have it in our repository. That's why I will add it in a special file called Git Ignore. Okay, it's going to ask me for the password, but I'm not going to add the password right now. Going to git add -a capital, which means that I'm going to add everything in the repository. I can ensure that I'm only adding the correct files by running git status. Yes, I have the package JSON, package log.json, index, and docker file, and the git ignore. I'm going to commit those changes, git commit -m initial commit. Now, before I push this code to CodeCommit, I'm gonna need to get the credentials. So I'm going to cat the username and password of the CodeCommit CSV file that I just downloaded, and now I can git push -set -upstream origin master. Once I do this, I need to supply the username and password, so I'm gonna supply exactly that, the username and the password, right? And now our code is pushed to CodeCommit. If we go now to CodeCommit and click on the repository, you're gonna see that now we have files. We have our Docker file, our index file, and package lock.json. So now we have our code commit ready to be our first step in the CI/CD pipeline. In order to start building our code for our CI pipeline, we need to use the CodeBuild service of AWS. So on the left-hand side, I'm going to go to Build, open it, and click on Build Projects. Going to create Build Project. As usual, the name is going to be Example App. I'm not going to have a build badge here because we're not going to use this for this project. In the source, I'm going to choose CodeCommit as the source, but as you can see, you have other sources. It's already integrated with GitHub, Bitbucket, and Amazon S3. In this specific example, I'm going to use CodeCommit. I'm going to choose a repository, which is Example App, and I'm going to choose the branch to be master, which means that the code is going to be pulled from this repository for the master branch, and whatever we want to do with this code is going to be done through the CodeBuild project. Now let's have a look at the environment. I'm going to use a managed image. I'm going to choose the operating system to be Ubuntu, and the runtime to be standard, and the image to be the AWS CodeBuild standard version 4, and the environment type, of course, is Linux. And I'm going to need to press on this privileged checkbox, and this is required because in this build project we are going to build a Docker image, so we need to have this privileged checkbox checked. And of course, it's going to create a new service role, and I need to copy this service role. I'm going to tell you why in a minute. And the build spec file is the name of the file that will contain the instructions that we need to build this project. I'm going to create this in our application repository, and we don't have any artifacts for this. And yeah, we need CloudWatch logs so that we can see what went wrong when we want to. And then I'm gonna create the build project. Now it has been created, and the reason why I copied the service account role name that it created for me is because I need to add some more permissions to this role. And the reason is that CodeBuild by default is your orchestrator in the AWS pipeline. It is where everything is done. The code is pulled, the code is built, the code is deployed perhaps to another service like ECS or EKS or EC2 instance. So you need to add whatever permissions CodeBuild needs to make the actions that you needed to do doable, if that makes sense. So let's search for that service role that CodeBuild created for us, and here it is. Let's click on it, and I need to attach a policy to this role, and I don't have a ready-made policy, so I'm gonna create my own. I'm gonna use JSON, and I'm gonna paste this code. So let's have a very quick look. This is a very straightforward JSON AWS policy. If you are not familiar with AWS policies, it just contains an action and a resource where this action applies, and an effect, either allow or deny. In this specific JSON policy, we are giving the CodeBuild access to ECR. This is the required access to that. CodeBuild can pull and push to ECR whenever it needs. So let's review this policy to ensure that it does not have any errors. So okay, we have a space at the end. Let's remove it. Let's also ensure that we don't have a space at the start. Okay, now let's again review the policy. And I'm gonna call this ECR, let's say example app, ECR authentication, and create policy. Now that has been created, I need to attach it to this role. First, I need to refresh the policies that I have, then search for example app, yes, ECR auth. Let's check this one and attach policy. Okay, now my CodeBuild has access to pull and push images to ECR. Now, in order for CodeBuild to be able to work, it needs a build spec file. The build spec file is a YAML file containing instructions as to how CodeBuild is going to build whatever code it pulls from CodeCommit or from whatever repository you configured it to pull code from. This is very similar to nearly all other pipelines. So you have a similar file in GitLab, you have a similar file in GitHub Actions, you have a similar file in Bitbucket pipelines. So let's move back to our terminal. And inside our repository, this file needs to exist in your repository. I'm going to create a file called buildspec.yml, and it has to be exactly that name, buildspec.yml. AWS expects to have a file with that name in the root of your repository. So let's open that file, and I'm going to paste code. Let's have a look at that code step by step. So the first, we have phases, and phases are just stages in the AWS code build terminology. It's just a step that indicates what you need to do. So for example, you have pre-build. In the pre-build stage, we issued a command that logs us into ECR. We've seen that command before in the terminal when we manually pushed our image. So first we need to authenticate ourselves to ECR, and then we extract the commit hash of the git commit. And the reason we are doing this is that we need this commit hash to recognize that image so that we can tie a commit hash to an image. So if something went wrong, for example, we can easily pinpoint which image caused that error or that bug, and then we can see the tag of that image. We're going to see that it's a git commit. We can go and search for that git commit and see what code exactly was introduced and caused the bug or caused the error. And notice here that we only extract the first 7 characters of the commit hash because it's such a long string. We need only the first 7 characters, and they are more than enough to recognize and make that image tag unique across your repository. Then we place a variable that is called image tag. You can just remove the latest for now. So the image tag is going to be the commit hash, and the rep URL is going to be just constructing the repository URL so that we have a variable that we can work with. Then we just build the image using Docker build, and we get the tag, which is the rep URL colon latest, and then we tag that same image again with the image tag, so that the result of this command is that we have 2 images, one latest and one with the image tag that is, as we said, the commit hash. Finally, we use the docker push command to push that image to ECR. Let's save that file, and as usual, we are going to add it to our repository by using git add, then git commit -m adds the build spec file. Then we are going to git push to our repository. Now let's go to our code build project, and if you notice in the build spec file we had some variables that needs to be supplied. So in order to supply those variables, we use the environment variables feature of code build. Gonna go to edit and then environment. Can add here environment variables that code build will use in its build. So we're gonna scroll down till environment variables, and we're gonna add the following environment variables. So we have AWS default region. Gonna set this to EU West 1. Gonna add another environment variable, AWS account ID. This is my account ID. I'm gonna take it from here. Just copy it and paste it. Then the image tag, then the image repo name. In this case, it's example app. Those are the environment variables that we need, and all of them are plain text. Later on, we're gonna see how we can add encrypted or confidential information that are encrypted. I'm gonna update the environment, and I'm going to start this build project. I'm not gonna change any of the default variables. I'm going to start build, and I can click on the tail logs button here in order to see exactly what's happening as it happens. Okay, and seems that we have a problem, which is that, as you can see, Docker has recently added some restrictions regarding how many times we pull images from their public repositories, and apparently we have reached that limit. So one possible workaround for this is to use ECR as the repository for our node so that we don't have to pull from Docker. So let's exit that. This will require that we first go to ECR from here. I'm gonna create a new repository. Let's keep it private as well, and gonna name this node create repository, and let's have a copy of the URL. Then I'm gonna tag node with this tag, and I'm gonna push our modified tagged image to ECR. Alright, then let's clear the screen, and I need to modify the Docker image, the Docker file. to, instead of using node latest, I'm gonna use our new image, which is exactly node, but we are just hosting it on our ECR repo instead of on the public Docker hub. Then let's add this Docker file now and commit with a message: modifies node base image to use ECR to avoid Docker rate restrictions, or whatever you need to supply as a description, and then git push. Okay, we are going to retry that build. Again, tail the logs. Seems that we have passed the rate limit problem and we have a success. So now if we have a look here, you're gonna see that we have this job succeeded. However, as you can see now, we are running those jobs manually. So whenever you want to run a build job, we need to start the build from this button. Ideally, this should be done automatically. This is how any CI/CD pipeline is operated. Whenever code is pushed to the master branch or some other configure branch, the pipeline should be triggered. That is the role of CodePipeline. So let's see how we can make this happen. So from the left-hand side, I'm going to go to Pipeline, Pipelines, create a pipeline, and as usual, I'm going to call this example app. I'm going to let this CodePipeline service create a new service role for us, and I'm going to leave everything at the defaults. Next, source provider is going to be CodeCommit. Repository name is example app. Branch name, of course, is master. Everything else is going to be left at the default. And the build provider, of course, is CodeBuild. The project is example app again. No extra environment variables are needed. Next. And I'm not going to use code deploy in this lab for deployment. Instead, I'm going to use CodeBuild for building and deploying my application. So I'm going to skip deploy stage. Yes, skip. I'm going to review and then create the pipeline. Now, what CodePipeline does is that it's going to ensure that whenever code is pushed to the master branch or the configured branch in the project settings, this code is going to be pulled from the CodeCommit repository and moved to CodeBuild to be built and for the build spec to be run against it. And as you can see, once I created the CodePipeline project, it automatically started its first pipeline task. So it pulled code from CodeCommit and now it is building it using our build pipeline. So if I go to a second tab, let's go to CodeBuild. And if you have a look here, you're going to see that we already have a build in progress. This in progress build has been started not by us, but by the CodePipeline. Right, now build has succeeded. And let's have a look at ECR and see what do we have so far. So Elastic Container Registry, example app, and you can see now that we have an image that has a tag and has latest. So now we can control which tag our image will have so that the latest will always point to the latest commit hash, but we can also choose that commit hash when we want to deploy a specific image to our infrastructure. We are now in a situation where anything that is pushed to master is going to be built and pushed to ECR as a Docker image. However, this is not normally how things are done in real-world scenarios. When you have a project, you typically do not push directly to master. Instead, you create a feature branch and you start creating or introducing new features in this branch, or perhaps solving a bug or something. And then when you are ready and you have done your tests and you're sure that your code works as expected, you create what's called a pull request, or in some other terminologies or other repos, it's called a merge request. Basically, a merge or a pull request is a request made by the developer to merge his code or her code with the master branch or the master trunk. Then a senior developer or another developer in the team has a look on the code and reviews it, and if everything is fine, they approve that code, and then it can be merged to master, where it gets deployed to the next stage. The idea of having a CI pipeline in place is that we also need to run some automated tests to aid the reviewer in their work. So whenever a PR or a pull request is created, we need to run a test job that will ensure that this code indeed is quality code and that it does not contain any errors or any bugs. And if everything is fine, it should notify the reviewer that an automated test has been run against this code and that it can be merged without any problems. This is what we're gonna do next. So let's move to our terminal, clear the screen, and we are going to create a test for our NodeJS application. In order to do that, we will need to install some helper packages. So using npm I or install whatever you want to use, we are going to install a package called Mocha and a package that is called super test. Just like that. Okay, both of them are installed, and if you have a look now at package.json, you're gonna see that now we have Mocha and super test as prerequisites for this application to work. So whenever you run npm install, those two dependencies will be installed along with Express. Alright, the next step is to modify this package.json so that it contains a test step. So I'm going to go to this file and I'm gonna go to test, and instead of echo error no test specified, I'm going to just remove this line and I'm gonna replace it with node_modules/.bin, because this is where Mocha executable gets installed. Mocha --exit, and that's it. Now whenever I want to test my application, I just need to run npm test, and that's it. However, currently Mocha does not have any tests to run, so we need to create those. This can be done by creating an empty directory that is called test. Then inside this directory, let's create a file that is called test.js, and let's add our test steps. For the sake of simplicity, we're not going to make any complex tests. We just need to ensure that the application returns 200 HTTP response code, which means OK, and that the response is JSON. So in order to achieve that, we are going to use this code. So nothing is fancy here. We just require index, which is the application bootstrap file, or actually the only file that the application has. And then we just ensure that the application returns 200 code, and it also has the JSON content type. Save that file, and let's move one step back to be in the root of our app directory, and then I'm going to run npm test. Okay, and we have one passing, and notice here that Mocha is going to start the application, run the tests, and it's going to exit. So you don't need to run node index.js to run the application and then use Mocha to establish an HTTP request. Mocha is going to do that automatically for you. So we are not JavaScript developers here, and we're not studying JavaScript. Instead, we are studying AWS CI/CD pipeline. So this is enough for us. Let's just test that this application test really works. So let's intentionally do something wrong with the application. So let's go to index.js, and instead of writing res.json, which is the response, we are going to add the following: res.status, and then I'm gonna give it the status of 500, which in HTTP means that it has an internal server error. And again, it's gonna return the same message, hello world, but instead of returning it with the code 200, which is the default, it's gonna return it with code 500. Now if I try to run npm test again with this code change, I'm gonna see that I have an error, and that is because it is expecting the response code to be 200, but instead it received 500, so this is an error. So now we are sure that our Mocha has our backs. It will always check our application for the errors that we have instructed it to check for. Let's now return our index.js to the way it was before. npm test. Again, we have one passing test. So now let's have a look at how we can implement these tests in our CI pipeline using CodeBuild. So currently we have the build spec.yml file, and this build spec is going to be used for deployment, or in other words, going to be used for the CD part of the CI/CD. It's going to be used for deployment or delivery. But for testing and integration, we are going to create a new build spec.yml file. And we're gonna call it, we can call it anything actually. I'm gonna call it build spec-test.yml. And I'm gonna add the following code. So this file is substantially smaller than the original build spec file. And because it does very little, it actually installs Node and npm and all the required libraries on the machine itself instead of using Docker. And then it runs npm install to install all the required package.json components or dependencies, and then it runs npm test. If that command runs successfully, then our tests run and are successful. If that command failed, then we have a fail test. So let's save that file. And now we have a bunch of files that need to be added. So package.json and package.json, of course, have been modified. We also have build spec test in a test directory. Let's add all of that and commit adds Mocha tests. Let's now push. Of course, this will automatically trigger the build pipeline, but we do not need it right now because we are going to create a new pipeline or a new build project specifically for testing. So let's go to our code build and let's create a new project. This time I'm gonna call it example app-test. Let's add the optional description just to inform whoever is viewing this why this project was created, QA for our application. And here I'm gonna enable build badge. I'm gonna see why in a moment. Again, we need the AWS CodeCommit repository example app, branch is gonna be master, operating system is Ubuntu, runtime is standard. I don't need privileged permissions here because I am not going to build or push any Docker images, and I don't need to make any changes to the service role that it just created. But now I'm going to use a different build spec file. So instead of using the default, I'm going to use build spec-test.yml. Everything is on the default, so I don't need to change anything and create my build project. Let's give it a try. Start build. Yes, it's a single build and I don't need to change anything, just start build, and let's have a look at the logs. Right, and we had a passing test here. That's great. So we have a successful build, but we need to trigger this build or this test project whenever code is committed or whenever a PR is created on CodeCommit. So in order to do that, we will need to create a Lambda function that will listen to the PR created event in CodeCommit and we'll use it to trigger that test project. So let's go to Lambda functions and I'm going to create a function, author from scratch. Let's call it example app PR raised, which indicates that this Lambda function is going to be triggered in response to a pull request raised on example app. Our code is going to be Python 3.8, and I'm not gonna touch anything here. I'm gonna create a function. Once the function is created, I need to add some more permissions for this function to work. So I'm gonna go to permissions. By default, Lambda creates a role for us which contains the very basic permissions that the Lambda function needs to function correctly. We are going to use that role and add some more permissions. So I'm going to attach policies, and I need this function to have AWS CodeBuild developer access, and I also need to create a policy for this specific function. So attach policies, I'm gonna create one, Json as we are used to, and I'm gonna paste those permissions. Basically, we need those permissions on CodeCommit. We need to post a comment, list pull requests, and get pull requests. Going to review the policy. Let's call that policy example app lambda policy, of course. Create the policy, and let's go back to our role and of course refresh, then search for example app lambda. Okay, attach the policy. That's all what we need. Let's go back to our Lambda function and go to the configuration. We are going to add the code in this window. The code is pretty straightforward. I have included that code in the repository so we can have a look at it in more detail. But basically what it does is that it will listen for a pull request being raised in CodeCommit repository. Once that is done, it is going to post a comment on that pull request informing the reviewer or whoever is viewing this PR that CodeBuild is going to be triggered in response to this PR, and it's going to test the code that has been pushed to this PR, and then it will also say that the results of this PR is going to be posted on that thread. Okay, so let's move on to the bottom because we will need an environment variable. If you have a look here at the code, you can see that we are using an environment variable that is called cb_project for CodeBuild project. Lambda needs to know which CodeBuild project it is going to trigger in response to this PR being raised. So this is added through an environment variable, cb_project, and the name of the project, of course, is going to be example app-test, the project that we have just created a few minutes ago. Gonna save this function, but now this function needs a trigger. So to create a trigger, I'm gonna go to Event Bridge. I'm gonna go to Rules. I'm going to create a rule. I'm gonna call it example app-pr-raised. Now I need to define a pattern. I will define a custom pattern because I need something specific here, and I'm going to paste this JSON code. So let's have a look quickly at what this JSON code does. It simply specifies that the source of this event is going to be CodeCommit, so Event Bridge is going to listen for events coming from CodeCommit, but not all events, specifically the pull request being created, all the pull request being updated. So whenever the developer updates the pull request in response perhaps to some bugs that appeared in the automated testing, he or she needs to work on those bugs and then push again some code. Then again, once it is pushed, the Lambda function is going to be triggered again, and the CodeBuild test project is going to be triggered again to test against those changes and post the results back, and so on and so forth. And also we need to define the branch that this event is going to listen to. Basically, it's going to listen to the master, but of course this can be changed. Of course, if you have, for example, a staging branch or a development branch, you can specify that branch name here. Gonna save. Then I'm going to define which target this event is going to hook to. So the target here will be a Lambda function, and of course Lambda function is example-pr-raised. Not gonna add any tags, and I'm going to create. So now we have a Lambda function that's gonna be triggered whenever a PR request or a pull request is triggered. So let's test that. Let's deploy our function, and if you have a look now, you'll see that it has Event Bridge CloudWatch events as a source of triggering this function. So to test it, let's go to our terminal and let's create a new branch, git checkout -b. Let's say develop or something similar, and let's go to index.js and change the greeting message to something like hello Lambda, for example. Save it. Git add index.js git commit -m changes the greeting message, and then of course git push, and we need to set the remote branch. Now let's go to our CodeCommit repository and create a pull request. The destination branch of course is master and the source is develop. Let's compare, and of course we have the change here, which is hello Lambda instead of hello world. Let's give this PR a title, changes the greeting message, and create the pull request. Now let's give it a few seconds, then go to activity, and as you can see here we have the Lambda function has commented on that PR. A pull request was raised or changed. QA is running now, and the results will appear here. Let's make sure that indeed that's the case. So let's go to example app test, and as you can see here I have a task in progress. and it has succeeded. However, in CodeCommit, we have no way of knowing whether the results of this PR PR test is a success or a failure. So that will be the role of another Lambda function that will take those results and display them in another comment on this PR. So let's go again to our Lambda functions window and go to functions, create function. This time is going to be called example app -QA results, which will be triggered, of course, after the QA is finished and we need to see the results. The code is going to be again Python 3.8, and in the permissions I'm going to change the execution role here because I want to use the role that the previous Lambda function was using. So let's search for example app, yes, and I'm going to create the function. Again, we need to add a trigger, so let's go to our event bridge and go to create rule. We're gonna name it example app -QA finished or results, whatever you want. And similarly, I'm gonna define an event pattern that is custom, and I'm gonna add the following JSON event. Let's expand this a little to see it. And as you can see here, we have the source now. Instead of CodeCommit as the previous function, we have here CodeBuild as our source. So event bridge is gonna listen for the events coming from CodeBuild, and specifically it's gonna listen for build status succeeded or failed. Let's save that. And of course the target is gonna be a Lambda function. This time it's gonna be our QA results function. And I'm gonna create this event bridge. Go back to QA results and let's add our code. Again, I'm not gonna go through the code, but you can have a look at this in the source Git repo that I have included with this video. But basically what this code does is that it will listen for the code build event, whether it was a success or a failure, and it's gonna reply to the PR with a comment containing the results of this code build test. So if it was a success or a failure, it will display the appropriate badge. This function does not need any environment variables, so I'm gonna just deploy it. Now if I refresh this page just to ensure that we have the correct trigger, you're gonna see that we have, yes, event bridge triggering this Lambda function. Right, again, to test this, I'm gonna go to the terminal and let's go to master and let's create another branch. So git checkout -b, and let's call this branch test, for example. And in this test branch, I'm going to intentionally do the same error that I did before. So I'm going to send the code 500. Okay, perhaps a developer was trying to specifically send the code in the response, and by mistake he or she sent the error code 500 instead of 300, for example, or any other legitimate code. So they made that change, and let's say the file git add index.js git commit -m changes the response HTTP code. Then git push. Let's get the command for setting the remote branch. Okay, now let's go to CodeCommit and let's close this PR, we don't need it. I'm gonna create a new one. So create a pull request. The destination is master and the source now is test. Let's compare. And as we can see here, we have our faulty code in green. Title of this is gonna be changes the HTTP response code and create a PR. In a few seconds, we are going to look at the activity, and we have our comment that the code build is triggered. Let's see that it's indeed being triggered. Yes, now it's in progress, and it should fail in a minute and a few seconds. Indeed, it failed. Now let's have a look at our CodeCommit PR, and let's refresh the page. Okay, Now we have the badge. That's why when we created the code build, we enabled the badge, and Lambda function now is copying the URL of this badge and pasting it here in the comment for this PR. So now whoever is viewing this PR can clearly see that it is failing, and maybe they want to know why it is failing. They can have a look at logs. Logs are stored in CloudWatch. And as you can see here, we have the error. Let's start at the beginning. Okay, one is failing. Ensure that correct response is received when requesting resource / should respond with 200 and JSON type. So clearly we have now like the root cause of why this test happened. And again, let's pretend that we are the developer who created the PR. Let's go and fix it. So vim index.js. Let's remove that faulty code. Perhaps change the greeting to hello AWS, for example. Git add index.js. Git commit -m fixes the incorrect response code. Git push to the same branch, which is test. Now moving back to CodeCommit, and in the same pull request, you're gonna see that we have now a new comment. So this is the fading comment. This is a new comment from the Lambda function because there was a change that happened to the PR. So it will trigger again the CodeBuild project to see whether or not this change indeed solves the problem or not. We had a typo here. Let's save it. Add git push. Now in a few seconds we should see another CodeBuild project being created, and the job succeeded as expected. Let's go to CodeCommit now and refresh. Alright, now we have a badge that our code is passing. Now if I am the reviewer, I can just have a look at the code and then merge to master. Now since this code is merged, we expect that the other build project, which is example app, is going to get triggered. Yes, as you can see here, it's in progress. It's now going to build the Docker image and push it to ECR. Now let's move to the final stage of our CI/CD pipeline. We have now completed the CI part. Let's move on to the CD, which is the continuous deployment or delivery. So far, our example app build, which is currently running, has only pushed images to ECR. Let's add a final step to this pipeline in order to make something meaningful other than just pushing the image, which is to deploy it to an EC2 instance. So let's leave this one to work, and let's open one of our tabs, go to EC2, and I'm going to create a small EC2 instance. Launch. I'm going to use Ubuntu server t3 small review on launch, and I'm gonna use this private key launch instance. Instance now is currently being launched. Let's have while it is being launched, let's spend a little time to adjust its security group. So I'm going to go to the security group and I'm going to edit the unbound rules. I'm going to add the HTTP port 80 because this is what our application listens to, and yeah, accept this from all sources. Let's move back to EC2 and wait for the instance to be running. Now it is. I'm going to deploy the private key first. Let's move to master. No need to go to test. Let's git pull for anything. Okay, now we are going to go to .ssh, AWS CI CD .pem. I'm gonna paste my private key. Ensure that it has the correct permissions. Okay, now let's take a copy of the IP address of the instance and log in using the user Ubuntu and the IP address of the machine. Once I'm inside, there are some preparations that need to be taken care of for this image to be able to serve our application. So I'm gonna run sudo apt update, then sudo apt install -y, Docker of course, .io, docker compose, and python 3 pip. Ideally, those packages need to be part of the AMI itself or get deployed using a configuration management tool like Ansible or Chef. Alright, and finally we need to install the AWS CLI since we now have pip. And let's also add Ubuntu to the Docker user group so that we don't need to use sudo whenever we want to use a Docker command. For this to work, we will need to restart our session. Then let's create a directory for our application. Let's call it app. And inside that directory, I'm going to create two files. The first one is going to be docker compose.yml. We're going to use docker compose for deployment. So our docker compose file is going to have the following. So we have a single service or a single application, which is example app. This is the image that we have on our ECR, complete with the prefix. And notice here that I have $sign tag, and this is an environment variable that I'm going to supply to docker compose at runtime, as I'm going to show you in just a minute. Of course, the port is port 80 on the host and port 3000 on the container, and restart always so that docker compose restarts the container if it failed. I'm going to save that file. Then I'm going to create the file that will actually does the deployment for us, which is deploy.sh. And this file is going to do a very simple task. It is going to accept a positional argument, which is $1, and it's going to assign that positional argument to the tag environment variable, and it's going to export it. And then it's going to use docker compose with of course, the environment variable is now set to bring down the application. If it is running, it will bring it down in order to modify it, and then it will bring it up in order to use the new image. So let's test that by first giving it execute permissions, and let's use deploy and pass in the latest as the positional argument. Yeah, we need to change that to docker compose.yaml. However, before we can apply this, we need to authenticate ourselves, of course, with ECR, and to have the appropriate permissions to pull images from ECR. So in order to do that, we will need to go back to our console and right click on the instance, go to security, modify Iam Role. We're going to attach a role to this instance. So let's create a new Iam Role, create role, and let's call it, of course, we need to specify that this role is going to be for EC2 instance because it's going to be an instance profile. And let's attach a policy. We can just attach the example app ECR authentication, which allows the principal to pull images from ECR. Next, tags, we don't need any tags. Review, let's call it example app -ec2 and create role. Okay, now we can move back to our EC2 instance and refresh. Then we're gonna find that we have example app -ec2, save. Now this instance has access to ECR, so let's move back to the instance. Now let's use the same old command that we used before to give us access to ECR. We've been using that for some time now. Pressing enter, and login succeeded. Now we can use deploy.sh to test the deployment, give it latest as the positional argument. And now, as you can see, it is indeed pulling images from ECR, and we have an application running. Now we can test that in the browser. Just ensure that we have the IP address of the machine. Let's open a new tab. Okay, and we have message hello AWS, which is the latest change that we did to the image to be hello AWS. Okay, now we need to add the steps that we have just did on the EC2 instance. Just add them to the build spec file so that it is automated. Once the image is pushed, it needs to be deployed to the EC2 instance. So let's exit from this instance and go to our build spec.yml file, and at the end of the post build command, I'm going to add 3 more commands. So we are going to grab the SSH key, I'm gonna show you in a moment how we can get this in an encrypted and secure way. We're gonna save it in the default location where SSH keys are saved. Then we are ensuring that it contains the correct permissions, which is 400. Then we are establishing an SSH connection to the instance. This is supposed to be the IP address of the instance. It's an environment variable that we're going to add in a moment. And it is going to go and execute the deploy.sh script that we have just explored a few seconds ago, passing in the image tag as the positional argument. So in the example, we passed latest, but in the pipeline, it should be the image hash or the commit hash. So let's save that. And before pushing it, we need to make a change or a number of changes to our CodeBuild project so that it can work with the changes that we made. So let's go to CodeBuild, and I'm going to edit environment, go to the environment variables that we had, add an environment variable. First, we need the SSH key, and this is going to be something that will be brought from the parameter store. So let's duplicate this tab. Let's go to the parameter store. Here it is. And here I have the SSH underscore key, which I have added before. And it contains the encrypted value of the SSH key that is used for this EC2 instance, for logging to the EC2 instance. So I'm going to go to CodeBuild and use that variable. It's called SSH key, and then inform CodeBuild that I need to get this key from a parameter rather than just plain text. So it gets it from the system manager here, and it's an encrypted value. I'm going to show it. It's just the private key that we used to log into our instance. Okay. Now the second is the instance itself, where we store the IP address of the EC2 instance, which is this one. So I'm going to copy it, paste it here, update. However, in order for this to work, I will need to also make a change to the role that CodeBuild uses to enable it to access the parameter store, specifically the SSH key parameter. So I'm going to go to IAM and search for the role that CodeBuild is using. Here it is, CodeBuild example app service role. I'm going to get inside, and then I'm going to choose any policy in those. Maybe let's have a look at this one. I'm going to edit the policy, Json. I'm going to add another action. It already has the SSN get parameters action, so I'm just going to add a second resource. Just need the ARN of that resource, SSH underscore key. Let's review the policy, save changes. Now CodeBuild has access to that environment variable in the parameter store. So let's move on back to the terminal. Git add build spec of YML, git commit -m adds the deployment step, and git push. Since this has been pushed directly to master, the example app build is going to get triggered in a moment. So let's get inside and see what happens. And the job succeeds. So let's now have a look at the full CI/CD pipeline. So I'm going to clear the screen, git checkout -b test CI/CD branch. I'm going to go to the index.js. I'm going to say hello from CI/CD, git add, git commit -message for m tests the complete workflow, git push, and copy and paste this command to create the remote branch. Now go to CodeCommit, example app, create a pull request. Source is test CI/CD compare. Change, of course, is changing the message. Testing the complete workflow. Create the pull request. Check the activity. We have the comment. go to code build. You're gonna see that we have the test in progress. Test has succeeded. You should see a comment on the PR. Yeah, the test is passing, so I can merge pull request. Then I should see the second pipeline is triggered, and it has succeeded. Now I expect that if I go to the instance IP address and refresh, I'm gonna see that hello from CI/CD is indeed displayed. So in this lab, we have seen how we can use the AWS code stack, CodeBuild, CodeCommit, CodePipeline, and Lambda functions to create a complete CI/CD pipeline where we can create pull requests, test those pull requests automatically, and then also merge and deploy to a staging or even a production environment. Thank you for watching this video. If you have any questions or comments, just drop me a comment, and see you in the next video.